Rapid microwave-assisted hydrothermal synthesis of copper bismutate and its application for the artificial photosynthesis. The paper was published in Materials Letters and was written by Lucas Ribeiro, Ivo Pinatti, Juliana Torres, Amanda Girotto, Fabiana Lessi, Elson Longo, Cauê Ribeiro, and André Nogueira. The increasing consumption of energy from fossil fuels and the rise in atmospheric carbon dioxide levels has raised considerable concerns about the effects on the climate and energy future. In this context, the artificial photosynthesis is a photocatalytic process to convert greenhouse gases to hydrocarbons is under intense investigation for this purpose. In this work, we synthesized copper bismutate nanoparticles through microwave-assisted hydrothermal synthesis using different times, aiming to observe the growth mechanisms and their influence on the catalyst activity for CO2 photoreduction. This method produced crystalline materials with controlled morphology using low temperatures and short processing time. The samples were subjected to CO2 photoreduction in the semiconductors showed excellent catalytic performance and selectivity in the conversion of CO2 to methane. Analysis of the liquid phase indicated acetone and isopropanol in all reactions, which have higher economic values and energy densities than C1 compounds. A fast and straightforward microwave-assisted hydrothermal route has been reported for the synthesis of copper bismutate with strict control of semiconductor structure and morphology. The materials showed excellent activities in CO2 photoreduction process, with a selectivity in the conversion of CO2 to methane. The results demonstrate a new strategy for quick and easy synthesis to obtain copper bismutate, providing an essential indication of activity in the CO2 photoreduction process. For further details, please see the paper published in Materials Letters.